You know that announcement at the airport, right? The one about the unattended bag? It's just a part of traveling, an annoyance. But what if I told you that that one suitcase, it's actually at the very center of a huge global race to build some of the world's most advanced surveillance AI? Yeah. So let's dig into how a simple lost bag is pushing the absolute boundaries of technology.
So why all the fuss? It really boils down to this one number, 54%. According to a U.S. Department of State study, 54% of terror attacks use explosives. And because of that one statistic, well, every single forgotten bag has to be treated as a potential worst-case scenario. It completely shapes the security response we all have to go through.
And that's why, because of that 54%, a single forgotten bag can literally shut down an entire airport. It goes from being a simple mistake to a major potential threat. And what happens next? You know it. Terminals get locked down, people are evacuated, and the costs for the airport just go through the roof. It's this massive, hugely disruptive problem, and it's all kicked off by someone just forgetting their luggage. Okay, so how do you even begin to solve a problem like this? You obviously can't compromise on safety, but shutting everything down all the time, that's just not sustainable. And this is where a new generation of AI comes in, offering a much, much smarter solution. And here's the real game changer. The goal isn't just to spot the bag anymore. It's to find the owner and find them fast. You see, older systems could only do one thing, flag a bag, which would immediately trigger a lockdown. But these new solutions, like one developed by Hitachi, are asking a way smarter question. Not just what was left behind, but who left it. The whole idea is to find that person in minutes, which could stop a full-scale shutdown before it even starts.
So picture a security officer looking at a screen just like this. They can literally click on the person who walked away from that bag, and the system becomes this high-speed digital detective. It instantly starts searching footage from every single camera on the network to track that person's exact path, all in real time. What that means is they can intercept the person, walk up and say, "Hey, is this your bag?" long before they have to hit the big red button for a full-blown evacuation.
Okay, that is just incredible technology, but it brings up a really interesting question. How does an AI even learn to see and follow one person through a totally chaotic airport? So let's pull back the curtain and take a look at the tech that makes all of this possible.
Well, the AI isn't just looking at pixels like a normal camera. It's actually trying to understand human behavior. It uses this technique called posture estimation, which basically creates a digital skeleton for every person it sees. By tracking the movement of these, joints, it can automatically recognize specific actions. Things like someone falling down, or in this case, something more suspicious, like someone passing an item over a barrier. Now, the engine that powers all of this is something called deep learning. The best way to think about it is like teaching a toddler to recognize a cat. You don't write a bunch of rules like has pointy ears or has a long tail. You just show them thousands and thousands of pictures of cats. Eventually, their brain just gets it. Deep learning is basically the same idea, but on a massive, massive scale. It lets the AI learn these incredibly complex visual patterns that no human could ever possibly program by hand.
Okay, now here's a really important distinction to make. There's face detection, and then there's face recognition. Detection is pretty simple. The AI just looks at an image and says, yep, there's a face here. But recognition, that's what really raises the stakes. It asks, whose face is this? By trying to match it against a database. Now, it's worth noting a lot of these modern tracking systems focus on the whole body, partly to avoid privacy issues. But understanding this difference, the difference between just seeing a face and actually knowing a name, is totally fundamental to how all this tech works. For any of this to work in the real world, speed is absolutely everything. You just can't afford to send huge video files to some server far away and then wait for an answer. And that's exactly why the whole industry is shifting to what's called edge computing. Basically, the brain gets put right inside the camera itself. All the heavy AI analysis happens right there, on the edge of the network. This completely eliminates lag and makes the system's response almost instantaneous. So how does the AI actually, follow someone through a crowded terminal? It's kind of like a two-step dance. First, a really efficient detection algorithm, something like MobileNet SSD, scans the video to find all the people and objects. Then, a second predictive algorithm, in this case, a Kalman filter, locks onto the target. You can think of it like a virtual spotlight that doesn't just follow them, but actually predicts their next few steps. And that's how the system can keep a lock on them, even if they disappear behind a pillar for a second or get lost in a crowd. So, we've seen the problem, the unattended bag, and the incredible tech being built to solve it. But now let's zoom out a bit. Who is actually building this future?
The global map of this AI race, well, it might not be what you think.
Now, you'd probably think that with all the headlines we see, surveillance is the main event in AI vision research, right? But a report from the Center for Security and Emerging Technology, or CSET, shows something really surprising. As you can see right here, dedicated research into surveillance tasks makes up only about 6% of the entire field. It's a surprisingly small slice of the overall AI pie.
But, and this is a huge but, when you zoom in on that little 6% niche, the story completely changes. Researchers from Chinese institutions are publishing a massive, massive share of the work. By 2019, as this chart shows, they were responsible for a staggering 42% of all the global research papers on these specific surveillance tasks.
So, what's going on here? Does this mean that AI labs in China are just obsessed with surveillance? Well, the data actually points to a much bigger, more nuanced story. The reason for this dominance isn't what it might seem like at first.
The real reason for China's dominance here isn't some narrow focus on surveillance. It's a huge national investment in the entire field of computer vision. I mean, look at this. Nearly 40% of all their AI research is dedicated to teaching computers how to see. That's way higher than the world average. They're just pouring so much energy and resources into the wider field that it naturally makes them leaders in all of its smaller niches, including surveillance.
And the CSEP report digs even deeper, splitting the research into two different buckets. You've got your established tasks, things like basic face recognition, where the growth is pretty slow and steady. But the real story is in the emerging tasks. Just look at the growth rates for things like person re-identification. We're talking over 30% a year. This is where the absolute cutting-edge innovation is happening, and the field is just exploding.
And this is where that massive Chinese focus on computer vision really pays off for them. In those fast-growing, emerging areas we just talked about, their dominance is even more pronounced. They are publishing well over half of all the research on person re-identification. That's the core technology you need to track someone from one camera to the next. This is the absolute frontier of surveillance AI, and it's being charted for the most part in one country.
Okay, so we've got these incredibly smart algorithms and this global race to perfect them. But there's one last piece of the puzzle. How do you actually make all of this work in a complex, real-world place, like an airport or a stadium?
And this right here is the future of security planning. Forget about guesswork and old-school blueprints. Companies like Hitachi are now creating what they call a digital twin, a perfect 2-scale 3D simulation of a building. Inside this virtual world, they can test thousands of different camera placements to find the absolute perfect layout. They can optimize the entire network, make sure the AI has 0 blind spots, and do it all before a single physical camera is ever installed.
And if you really want to understand the ultimate ambition behind all this technology, this quote from the Hitachi research team says it all. They say that reliable video analysis will need to, and I quote, expand to cover all corners of society. So the goal isn't just about securing airports, it's about creating a blanket of AI-powered analysis that covers, well, everything. And that brings us right back to where we started. The technology to solve the unattended bag problem is here, and it's evolving at an incredible speed into this pervasive predictive network. So the next time you hear that announcement at the airport, the question to ask yourself isn't just, when is my flight going to board? The real question is, as these cameras get smarter and smarter, what rules should they follow? The technology is ready. The conversation about those rules, well, that's just getting started.